Our overall goal of learning statistics at the introductory level is to learn to distinguish between statistical conclusions that are likely to be valid and those that are seriously flawed. Good critical thinking skills, in addition to statistical literacy, are needed to make these distinctions. We might generalize this by saying that we want to use common sense to analyze statistical data. So let's look at some common ways that statistical data can be misleading. A voluntary response sample. This is where respondents decide if they want to be included in the sample. It's also called a self-selected sample. And these are done, you'll see them on the internet, you may get one in the mail, a phone survey, and usually only people with either strong opinions or people who have time will actually respond to those. And the result is you don't get a sample that represents your population. Now it doesn't mean that these aren't used. They are used, and they obviously, and they do get some kind of information from them, but it's not a true statistical analysis. It would just be a good way just to get some information, but you would be wary of drawing statistical conclusions from such samples. Small samples. Now we'll talk about this more in future videos, but for now we need to understand that conclusions should not be based on samples that are far too small. Misleading graphs. Now graphs can be misleading by exaggerating or understating the nature of the data. And it doesn't mean that the person who created the graph intended to mislead. And that's true of all of these. It's just that it can happen, and those who do prepare things like that should realize that there are ways to do bad graphs and ways to prepare graphs that are more representative of the data. But as the consumer or the person who is interpreting these graphs, we need to be aware of some ways that graphs can be misleading. One way has to do with scale. So say a test was given and the results of the test were summarized by males and females, and we saw this graph as the result. So the average score for females was 90, the average score for males was 85, but by showing us just the top of the scale, it looks almost as though the females did twice as well as the males did on the exam, when really the difference was just 5 points. So the problem with this is that the scale does not begin at 0, and that can make the results look more dramatic, not starting at 0, see? So clearly this might start, looks like it starts about 80, right? So the top of the graph is more dramatic, and by only showing us the top of the graph, we get the idea that females did about twice had about twice the outcome as the males, which is definitely misleading. So scale is one way that graphs can mislead us. Another way is with the use of something called pictographs. Here's an example where the idea was to get across this one-dimensional piece of data, the price of tickets at baseball games and basketball games from 1991 to 10 years later, 2001. That's a one-dimensional value, the price of a ticket. But we're using this two-dimensional, or even in our eyes, you know, a ball is three-dimensional, so we might even take it that far in our mind that this is three-dimensional picture or a pictograph trying to get across this one dimension of ticket prices, the data there. So it can give us a misrepresented relationship between the price in 91 and 2001. So you look at the baseball. It looks like the price of the ticket was just under $10, the average price of a ticket, and then it goes to 20. Well, that's, you know, about twice as much in 10 years. But the second ball looks much bigger than just 2 times the size of the first ball. And likewise with the basketball. The second one looks much, much bigger than just the increase from, I don't know, say $22 a ticket to $50 a ticket. So we want to be careful when we see one-dimensional data represented by two-dimensional and three-dimensional figures called pictographs, because even though that can be very eye-catching and pleasant to look at, it can misrepresent the relationships in the data. Another way data can be misleading is through misleading percentages. And what we mean here is, that percents can be stated incorrectly, whether intentionally or not, and we have to be careful to evaluate them or we'll be misled. And just remember, if you're taking 100% of some quantity, you're taking it all. So, for example, if a hotel claims it reduced complaints by 100%, that means they reduced all complaints down to 0, and that's probably not true. So we want to be aware of those kinds of claims. Loaded questions. When surveys are written, the questions can be worded to elicit a desired response. Again, this might be unintentional, just due to the experience of the survey writer, or it might be intentional. People tend to want to please the person who's asking them the questions. And so, for example, if, say, there was a survey that asked, "Don't you agree that the seniors in our town deserve a new senior center?" Well, the opinion of the researcher is quite obviously in that question. It's obvious in that question. You know that they really think that, yeah, we should build a new senior center. But a better way to ask that question to get the true responses of your population would be, "A new senior center should be built in our town. Do you agree or disagree?" Now, by wording it that way, you have no idea what my personal opinion is about that. So you should feel free to answer in whatever way you think you believe, right? Better data is then achieved through that survey. The order that questions are listed on a survey can also make a difference. And so you might think about a time when you've taken a test, and after you answered the first question, a question later on triggered a thought and you wanted to go back or either change or add to your answer. And that could happen on a survey too. But people don't usually aren't usually able to, or maybe just don't go back and make corrections after they read another one. You might get more context from the survey and think, oh, that's what they're talking about. Well, let me go back to the first one and change it. But people just won't do that usually, take the time to do that. So you're not getting good responses. Correlation and causality. Okay, what that means is that when we find a statistical association between two variables, we can't automatically conclude that one of them is the cause of the other. So if you read that in a study, the results of a study, and they say, well, we found that as this variable increased, this other variable also increased, then if they just directly conclude, well, one caused the other, you should be suspicious of that. It could be that that's true, but not necessarily. So let's look at definition of these two terms. So when we say correlation, that represents a mathematical relationship between two things that are measured. Whereas causality means that one thing happening actually causes another thing to happen. So we want to be careful to claim that correlation does result in causality. For an example, if they studied workers and they measured how happy people were at their job, and they found that a happy worker led to a productive worker. And they claimed, well, employers, all you need to do is make your people happy and they'll be more productive. You know, put free coffee in the break room, you know, whatever, hang up pleasant pictures around the office, things to make people happier, they'll be more productive. Jumping to that claim is not necessarily the right way to go. There could be another variable involved, and in fact, in this situation, the skills and job match is another variable that is probably affecting this. In other words, That's an and. In other words, the better a person's skills are matched to the work they're doing, the more productive they'll be and the happier they'll be. So there's this third variable that as you get better and better skill to job matches, you get happier workers that are more productive. If people do not feel that their skills match their job well, what they're expected to do, they're less productive and they're probably not very happy with their job. So we want to be aware that there might be another variable causing the variables we looked at, those two things, to either go up or down. And so that's why we don't automatically assume that one causes the other. The next way a study can be misleading is if it uses what we call precise numbers. This is when a precise figure is used. It tends to make us believe it's accurate if it sounds like they actually calculated to that very precise level. So, for example, if a study concluded there are 103,260,293 households in the U.S., that implies that they actually calculated to that mark of 90, this 3 right here. So that is misleading because most likely they didn't do that. And a better way to say this would be to say that there are approximately 103 million households in the U.S. By implying that they did that, it makes us question the whole study. Okay, so you'd want to be leery of any study that used precise numbers like that if it didn't seem possible that they'd really get to that exact number. Okay, and last we have what's called self-interest study. And self-interest studies are studies in which the researcher has an invested interest in the outcome of the study. So while this doesn't necessarily mean that the study was biased, it certainly suggests that we should subject the study to extra scrutiny. For example, if a pharmaceutical company is providing the money to have research done on the drugs that they manufacture, even if they aren't doing the research, but they're just providing the funding for that, we should be a little bit suspicious of that, especially if the outcomes claim that the drugs are, just perfect and doing everything that they have claimed that they are, and that they're something that everybody would want, right? So we'd want to question that since they did the funding, or if they actually do the research themselves. So we want to make sure we know who did the study. That's always a good question. Who funded it? Who did it? Okay, so that's a good summary of some things that we want to look for when we read research, and to be more aware, a better consumer, better citizen, and more critical thinker.